Hello, and welcome to Team of Pharma Talks. My name is Brian Svaton. I'm the president of Nikka Densok, USA. What a wonderful day for these talks today, and what a beautiful place. Today I'll be speaking about our company, Nikka Densok, and presenting what our technology is and how it's a potential solution for the recently effective Annex 1 in regards to CCIT. Nikka Densok is a specialist in leak detection testing using high voltage. So Nikka Densok first used AC voltage to detect leaks in pharmaceutical packaging in 1972. There's currently over 1,000 HVLD machines for both food and pharma worldwide in over 43 countries. We manufacture inline high-speed production equipment as well as laboratory HVLD machines to inspect glass ampules, vials, BFS cards, IV bags, and pre-filled syringes. Nikka Densok is a privately held company in Japan with our manufacturing facility just outside of Tokyo. We also have global sales and service offices in Golden, Colorado, Budapest, Hungary, and of course our factory pictured in the center right outside of Tokyo. So, high voltage leak detection, what is it? We're going to discuss the capabilities. We provide 100% consistent inspection. It's a non-destructive, deterministic technology, currently being challenged down to 5-micron size defects in production. Our speeds are capable of over 400 pieces a minute in some glass applications. We have the ability for streamless upstream and downstream integration. So what is high voltage leak inspection? We're going to dive into the principle of it to give a better explanation so that you can understand what it is that we're doing. So high voltage leak detection is capable of handling any liquid product as long as it meets the following criteria. The container is made of an electrically insulated material and it contains an electrically conductive solution. So the high voltage is seeking the least resistive path to the product. And a good versus a bad container is determined by measuring the AC volume of current. So a sealed container equals a consistent signal by allowing current to flow around the outside of the container, and a defective container is equal to the high signal due to a pathway of current through the liquid product. So here's a visual representation of how the inspection works. On the left, we have a BFS container where product is being exposed to high voltage. So we have V on the left is our power source, the high voltage, where R is the electric resistance of the solution, and C1 is the electric resistance between the electrode and the solution, the air in the container. So C2 is the electric resistance between the electrode and the solution and the air in the container, where I1 is representing a good container where we have an intact product, and I2 is representing a defective product where you have a pathway through the conductive liquid product. This ultimately results in a higher current flow, and we're able to detect this and flag it as a bad product. It's a breach in sterility. So what does this mean with regards to Annex 1? So the final version of Annex 1 was published on August 25th of 2022, about 7 years after the revision process started. The revised annex became effective on August 25th of 2023. So what does this mean for product leak inspection? Section 8.22, we're going to take a deeper dive into this. It states where final containers are closed by fusion, for example, blow-fill seal, BFS containers, or form-fill seal, FFS. Small and large volume perennials, SVP and LVP bags, glass, or plastic ampules, the critical parameters and variables that affect seal integrity should be evaluated, determined, efficiently controlled and monitored during operations. Glass ampules, BFS units, and small volume containers less than 100 milliliters closed by fusion should be subject to 100% integrity testing using validated methods. For large volume containers over 100 milliliters closed by fusion, reduced sampling may be acceptable or scientifically justified and based on data demonstrating the consistency of existing processes and a high level of process control. It should be noted that visual inspection is not considered an acceptable integrity test method. Now, this continued also addresses samples of products using systems other than fusion should be taken and checked for integrity testing using validated methods. The frequency of testing should be based on the knowledge and experience of the container closure system being used. A scientifically justified sampling plan should be used. The sampling size should be based on information such as supplier management, packaging component specifications, and process knowledge. So what does this mean? What does 100% inspection mean? Anybody? So we're going to focus on this question here. And specifically, where final containers are closed by fusion, BFS, form fill seal, the critical parameters and variables that affect seal integrity should be evaluated, determined, and effectively controlled and monitored during operation. So reiterating these points from the previous slides, the concept of this chapter is to control and monitor the seal integrity by fusion because it's at risk where the integrity is damaged. So specifically 100% of the product being produced, 100% of the fused area. So Nikka Densok offers several different machines for different products related to fused inspection areas. So IV bags, for example. So for example, on an IV bag, if you have a fused fill port, this is now required to be inspected. So depending on your bag, this is a non-fused area, this is an inserted. So this is required to be inspected, all fused areas. So if your container, if the perimeter of the bag is fused, that needs to be inspected. We can also inspect the fill port if it's fused. So the critical areas for IV bags are the perimeters of the bags if they're fused by heat, and also the fill port if it's closed by fusion. BFS, the critical point, is the joint mold line. So depending upon where your joint mold line is located, we offer a solution to inspect your BFS cards. Glass ampules and vial inspection. The critical point for ampules is going to be the tip. We also offer inspection areas of the other parts of your ampules and vials. And as mentioned by Annex 1, if it's closed by another means, a vial for example, it's stoppered and capped, it's recommended that that's inspected as well, but it doesn't need to be the same method, the same, pardon me. We also offer inspection of larger containers as well. Our BFS bottles, the critical areas, and all of the equipment is CFR 21 Part 11 compliant. And small bottles as well. So the critical areas and the fused areas of your small bottles. Pre-filled syringe inspection is also available in both inline high-speed machines and offline laboratory equipment. And lastly, we have sachet inspection for both food and pharma. And to wrap it up, we have our reference page. So thank you, everybody. If anyone has any questions, I'm happy to answer questions or wait until the end.
Thank you for the insightful presentation and speech. My question is, are there any unforeseen consequences with the high voltage being passed through the product, let's say, like degradation? So can we use this inspection method for all the liquids, which meets the two parameters you said, unconductive primary packaging and conductive product?
Great question. So the high voltage is considered a non-destructive deterministic method. We do recommend that you do your due diligence and make sure that your product does not degrade with the exposure of the high voltage. For that, we can offer services to expose your product so that you can perform that testing.
Okay, thank you for the answer.
All right, anybody else? Say again?
Maybe you want to ask who is manufacturing BFS products?
Sure.
And could be interesting questions from BFS production. Yes? You have any question? You don't have? Not now. Maybe at questions and answers. Buyurun Cankut Bey.
Thank you. For BFS products, maybe 5 microns is a challenge. It is very difficult, I think, for the BFS products. What do you think about the detectable pinhole for the BFS?
It could be, depending on the conductivity of the product and the size of the product. So we recommend testing a variety of sizes, starting with 5 micron and working yourself up to 10, 20, 30, and determining what is detectable and what is repeatable.
Do you have challenge tests for these machines?
We do. We recommend that laser samples be produced. So you can have laser samples produced in a variety of sizes, and you can see the exact performance of the equipment.
Thank you.
Başka soru sormak isteyen var mı? Tahsin Bey.
Hi, Brian.
Hi.
For BFS ampoules, according to risk management, you can choose the risky point of the containers, and you can check, you can detect the death point only. But is that possible to make a test for the full body of the ampoules with high voltage leak detection method?
So it really depends on the size of the container. It's possible with the larger containers. The 0.5, 0.3, it's challenging due to the principle of the high voltage. You'll start to arc across from the high voltage to the ground side. So that really needs to be determined with your specific product to see if we can inspect 100% of the body for your specific product.
Also, the second is the up to 5 microns. You can detect pinhole, but we cannot say if to talk about the stability, this is not the only limit, because if less than 5 microns pinholes on the ampoules, maybe there's a risk for the stability. Is there any improvements on your test method? Maybe in the future you can test it less than 5 microns. Is that possible?
We need to challenge the equipment in order to determine that with your specific product. So the factors involved with inspection, the conductivity, the fill volume, it's all relative. So the technology is capable of 0.1 micron detection, but it's relative to those factors, being the conductivity, the amount of head space. So we really have to test your specific product to be able to determine that.
Okay, thank you so much.
Başka soru sormak isteyen var mı?